Hello everyone. For my presentation, I want to talk about how we can use one of the equations we learned in class to help us in a game, basically. So let's say we are some distance away from your enemy, and we want to figure out the, the angle that we have to aim for us to successfully hit our target at this distance. And the equation that we're going to use is the equation, r is equal to initial velocity squared times sine 2 theta over g. So the first step we're going to take is going to find the distance between you and the other person. So let's do that. Alright, so we're going to do this experiment in this game called Battlefield 5. And where my tank is right now is pretty much where my friend is going to be standing, and where my mouse is pointing at right now is going to be where I'm going to be standing from. And to measure the distance from here to where I'll be standing, I decided to use Churchill's to measure the distance from here to there. And I'm making these marks on the ground to basically help me know where I will start or stop my tank. So basically they act as kind of a reference point in helping me measure the distance. Alright, so after doing the experiment, it turns out it takes 26 Churchill tanks to get from where my friend will be standing to where I will be standing. And from what I found online, each Churchill is 7.44 meters long. So to calculate the distance between the two of us, we multiply 7.44 by 26, and that gets us the number roughly 342.24 meters. So this will be the number that we'll use for r in the equation. Next, we're going to calculate the gravity that's inside the game. We can do this by the use of the equation height is equal to 1/2 gt squared. We can find height by comparing our height to the car in front of me. Since the height of the car is pretty much identical to the height where we're firing from, and a quick search online reveals that the height of the car is about 1.7 meters. So now we just have to calculate the t portion, and we can do this by timing how long it will take for the rocket to hit the ground. After doing the experiment, I got 0.8. After doing the experiment, I found out that it takes about 0.8 seconds for the rocket to hit the ground. So we'll replace t with the 0.8. And after solving for g, I got 5.3125 meters per second squared as gravity. After finding all the parts to the component to this equation, we can start plugging in numbers. So r, which we got, was about 342.42 meters. Opposite way around. It's 342.24 meters. Oops, okay. And gravity, which we got as 5.3125, and the initial velocity of the bullet, which I found online, turned out to be 500 meters per second. So we'll replace that with 500. Now solving for theta, I got a number that's close to 0.21 degrees, which is a little bit small. But we'll take it out to testing and see if it's correct. Alright. Okay. So this is it. The experiment reveals that we actually need to aim more than 0.21 degrees above horizontal to hit a target that's 342 meters away. Um, why this happened? I'm not sure. But it might be because there are some other factors that affect the bullet's travel in mid-air that I do not know how to calculate yet. But thank you all for watching. If you guys know what that factor is, please let me know.